Hello dear students, welcome back. In the last class we discussed about electric energy, isn't it? What was electric energy? The work done by an electric current in an electric circuit, which is called electric energy. So that was the work done. Today we are going to discuss about a measurement based on this work done. How fast the work done or how slow the work done. So the rate at which the work is done in an electric circuit, which is defined as the power of electric power of a circuit. That is, electric power is the rate at which work is done in an electric circuit. How can we compare this work done? Actually, I already told that whenever we see the term the rate at which, we are comparing that physical quantity to the time taken. So the rate at which work is done in an electric circuit, which is known as power. So to understand it practically, in practical language, we can tell that it's simply the energy consumed, the rate at which energy is consumed or dissipated by any electrical equipment. For example, let it be an electric bulb. So when you examine this electric bulb, you can see it will be written there 15 watt or 30 watt, 30 W, like that something will be written there according to each electric devices. So that gives us an idea about how much power it takes, how much energy it will consume. So power is simply the measurement of the rate at which electric energy is consumed or dissipated. So see here, equation for power is W by T, that is the rate at which work is done or the rate at which electric energy is consumed, rate at which energy is consumed, that is power. See, we know the equation for work, W equal to VIT. We studied different equations based on this work VIT or such like I square RT, such type of equations we studied. Now we are taking, for instance, W equal to VIT. Now substituting that value here we substituted what? W equal to VIT. So substituting the value of W in the equation, we get P equal to VIT by T. We can cancel the T, we will get P equal to VI. So this is the first equation for power. This is the general equation for power, and here we have the first equation, P equal to V into I, that is potential difference into current across the conductor. Now here we can replace V with another equation. We know connecting I and R, we have another equation for V equal to IR, isn't it? V equal to IR. Therefore, when we substitute this value here, V equal to IR, we'll get IR into I. What is IR into I? I into I means I square. So there is another equation for P, that is I square R. So we got two equations. See here, from the equation W by T, we substitute VIT for W and got the equation VI. Now here P equal to V into I, substituting IR for V, we got P equal to I square into R. How it came? I into I equal to I square, R we write here. So P equal to I square R. Now going to the third equation, we can substitute for, here we substituted for V, isn't it? In the same step, what happens when we substitute for I? We can check. I is equal to, what is the equation for I? I equal to V by R, isn't it? So from the first equation, if we substitute for V, we got I square R. Let's check what if we substituted for I. So P equal to, the equation is P equal to V into I. Now we are substituting for I equal to V by R. So V into V by R, I becomes V by R. See here, V into V is V square. So therefore, the equation becomes P equal to V square by R. That is the third equation. So from the general equation, we got the first equation, second equation and third equation. Once more, P equal to VI, P equal to I square R, or P equal to V square by R. So if in the problem only work done and time is given, we can find power by using this method. If potential difference and current is given, we can find P by using the first equation. If current and resistance is only given, we can find power using the second equation. And last one, if potential difference and resistance are only given, we can find power by the equation P equal to V square by R. Hope it is clear for you. Now, let me rub this. So we got three equations. Now let's take the first equation, P equal to V into I. See here, for every physical quantity, there must be a unit, isn't it? Unit of potential difference is volt, unit of I or electric current is ampere. So we can check what is the unit of P. Unit of power is watt. W represented by using the letter W. Unit is watt. Unit of power is watt. Don't forget. And now we can define 1 watt. How can we define 1 watt? See, in the equation of power, let's substitute the values as like it is. Unit of power is 1 watt. Unit of potential difference is 1 volt. Unit of current, electric current is ampere. So if it is 1 watt, it is 1 volt into 1 ampere. So now how can we define 1 watt? So 1 watt is the power dissipated or power consumed by an electric circuit in which 1 ampere of current flows through it across a 1 volt potential difference. Once more, how to define 1 watt? 1 watt is the electric power of a circuit in which 1 ampere of current flows through it across a potential difference of 1 volt. Across a potential difference of 1 volt. So this is how we define 1 watt. So once more, retaking from first, we defined an equation. We defined power. Find 3 different equations for power from the general equation P equal to W by T. The first one was VI. From this equation, we got the definition for unit power. That is 1 watt equal to 1 volt into 1 ampere. 1 watt is the power of an electric circuit when 1 ampere of current flows through the conductor across a 1 volt potential difference. So that's all about electric power. Now coming into the case, the commercial unit of electric power. So this watt is the unit of electric power. But in our home, in everyone's home, there is a electric meter, isn't it? KSCB gives us an electric meter in order to check how many energy we consumed every day, isn't it? So actually in their machine you can see instead of watt you can see kilowatt. Kilowatt. So what is kilowatt? 1000 watt is equal to 1 kilowatt. So if you consume 1000 watt is equivalent to consuming 1 kilowatt. So in electric meters which is provided by KSCB you can see kilowatt and another unit along with this kWh, that is kilowatt hour. Therefore these meters, electric meters, are also known as kilowatt hour meters. And one more name for this one, that is BOTU. What is that? It's not BOTU, BOTU, Board of Trade Unit. That is, for commercial purpose, we will not be using the term watt. Instead of that, we will be using either kilowatt hour or BOTU. 1 BOTU or 1 kilowatt hour. That is the unit, commercial unit of electric current. So in your KSCB provided electric meters, you can see kilowatt hour, 1 kilowatt hour or 2 kilowatt hour. According to the usage, it will be running there. So now let's define let's find out what is 1 kilowatt hour. So we know 1 kilowatt hour is equivalent to 1000 watt. 1000 watt into hour. How can we convert hour into seconds? 60 into 60, isn't it? So if we multiply 60 by 60, we get 1000 into 60 into 60 is 3600 watt, and the unit of time is second. Watt into second. Well, we have the equation for power is equal to W by T, isn't it? We have the equation for power is equal to W by T. What is the unit of power? Unit of power is watt. Unit of work or energy is joule. Unit of time is second. So when I take this second to here, it becomes watt second, which is equal to the unit joule. See here, watt second is an unit equivalent to joule. So instead of watt seconds, I can write here joule. See, joule. Now 1000 into 3600 joule. What it is? 36 into 1, 2, 3, 4, 5. So either I can write it as 36 and 5 zeros, 1, 2, 3, 4, 5, or from this point I am taking the decimal point to here. So 1, 2, 3, 4, 5, 6. So if I bring the decimal points to here, I am moving 6 points once more from here to 1, 2, 3, 4, 5, 6. So 3.6 into 10 raised to 6 joule. You can write so 10 raised to 6 joule, which is equal to 3.6 megajoule. What is megajoule? See here, we can write 10 raised to 3 joule is equal to 1 kilojoule, isn't it? What is 10 raised to 3? 1000 joule. 1000 joule is equal to 1 kilojoule. Such like that, 10 raised to 6 joule is equal to 1 megajoule. So instead of this 10 raised to 6 joule, we can write megajoule. So that is 3.6 megajoule. So 1 kilowatt hour or 1 unit is equal to 3.6 megajoule. So that's all about the portion power and commercial unit of power. What is the unit of power? That is watt. Commercial unit of power is kilowatt hour. Thank you for watching. If you have any doubt, you can contact me.